Okay guys, this is the Mixed Gas Law Worksheet, and this is video 10 from Chapter 10, 3B. We're going to do just one question together from this worksheet, so you need to pull it out and make sure you're ready. So a toy balloon with air has a pressure of 1.25 atmospheres, so that's your pressure unit right here, and a volume of 2.5 liters. If I take the balloon to the bottom of the ocean where the pressure is 95 atmospheres, that's a pressure 2. What will the new volume, that's a V2, of the balloon be, and how many moles of gas does the balloon hold? Now we're going to assume that the temperature at the bottom of the ocean is 276. Okay, so we've got a couple of different, this is going to involve two questions. Notice we have two pressures and two volumes, okay? Two pressures and two volumes. So the first one is, what's the new volume? Well, since I have pressure and volume, I know P1, pressure 1 is 1.25 atmospheres. It says volume 1 is 2.50 liters. And then it says if you take the balloon to the bottom where the pressure has changed and the pressure is now 95 atmospheres, it's asking me what's the new volume. Okay? At the bottom, what will it be there? So that's going to be my first question. So I'm going to have to use a formula that uses just pressure and volume. So that's P1V1 equals P2V2, which is Boyle's law. So I'm going to fill it in. Notice I've already got my pressure units already matched. So I just have to fill this in and solve for V2. So P1 is 1.25 atmospheres. V1 is 2.50 liters. P2 is 95 atmospheres. V2 is my unknown. Divide both sides by 95 atmospheres so I can isolate my V2 and cancel my units over here, atmosphere and atmosphere. I have just liters. All right, when I do the math, 1.25 times 2.5 divided by 95, I get 0.033 liters, and that's 2 sig figs because this number has 2 sig figs. So V2, what would the new volume be? The new volume would be 0.033 liters. Okay? Now it's asking me how many moles of gas does a balloon hold? And I'm going to assume that the temperature at the bottom of the ocean is 276 kelvins. Okay, so now I have a temperature, I have a volume, and I have a pressure. The pressure at the bottom, the volume at the bottom, and the temperature at the bottom. So P and a V and a T, so PV equals nRT. I have all those units. I have a pressure, a volume, and a temperature. A pressure, a volume, and a temperature, and I can always look up the R. But this is asking me for the number of moles, so I'm going to solve for N again. And we don't always solve for N, we solve for other things. We're going to divide by RT, so we have N by itself. So N is pressure times volume over RT. My pressure is 95 atmospheres. My volume I just calculated, 0.033 liters. My temperature is 276 kelvins. Alright, and so now I have to get the right R value. And I have atmospheres and liters, and if you look on your reference chart, the R value that has atmospheres and liters and kelvins is 0.0821 liters times atmospheres over moles times kelvins. So that's the R value. You would get this from your reference charts where I'm going to give them to you. We have just the different options. I think in the Prezi, that one is there too. Let's see, liter, there it is, 0.821 liters times atmospheres over volume, moles times kelvins. All right, so I put that in, 0.0821 liters times atmospheres over moles times kelvins. It's that whole thing. And now we got to cancel out all the individual units. Atmospheres and atmospheres, liters and liters, kelvins and kelvins. Moles is the only thing that I didn't cancel out. It is asking for moles. And so I'm going to pull the calculator up this time and show you how to do the calculation. and it is 95 times 0.033, and we're going to divide by 0.0821, and I'm going to divide again by 276, and I get 0.138, so 0.138. And then sig figs, there's only 2 sig figs in this number, so I have to have 2 here. 0.14 moles. That's the number of moles they asked for. How many moles of gas does the balloon hold? 0.14 moles. Now notice that in molar volume, everything had to be STP. But this one, we have different temperatures and different pressures. So the number of moles changes based on the Newton temperature. I mean, the number of moles can still be calculated with different temperatures and pressures. Okay, that's number 4. You'll be assigned other questions from this worksheet. I'll see you later.